Okay, sorry, it wasn't showing that I was recording. Now it is showing. Excuse me. Lesson 8.7. Again, we're going to be working with a standard form of a trinomial ax squared plus bx plus c equals 0. Sometimes called a quadratic, right? Okay, so we have factored trinomials that are like this, that have x squared plus bx plus c, right? And in that case, the x squared plus bx plus c, we know that our a has been 1, right? Well, now we're going to be factoring trinomials that in that same form, but in this case, the a is going to be some number other than 1. Or one vocabulary word will be a prime polynomial, and we'll look and see what that is. And basically on the bottom here it just said what I just said, that that a is going to be something greater than 1. So you can read that if you want, but that's basically exactly what I just said. Okay. Okay, here we have, I'm going to move this guy someplace else. Goodbye. Thank you. All right, apply the pattern 2x squared plus 5x plus 3. All right, so we've had this sort of a thing before. 2x squared plus 5x plus 3. You know, if we think of it, we're thinking about excuse me, x squared plus 5x plus 3, right? So a is 2, b is 5, and c is 3 plus 3. Sorry, I didn't really mean to say that, did I? Ax squared, sorry, my sneezing got me off, plus bx plus c, right? C is 3, b is 5, and our a is 2. All right, we're going to think about it in the form where right now, let's look at the 2x and look at the 3. And remember that this is like m plus p that we've talked about before when we were solving it when the a was 1, okay? So we're going to do basically the same thing. It's just a little bit different. We're going to find two numbers that have a product, this time a product of the 2 and the 3. So instead of just having a product of that is the 3, we're going to actually have the 2 and the 3, or 6, and then we'll have it have a sum of 5. So just a little variation on what we've been doing. Okay, so we'll look for factors of 6, right? Because 2 times 3 is 6. So we're looking for factors of 6, right? And we think of 1 and 6, and we think of 2 and 3. Well, which of those can add up or have a sum of 5? And of course it is the 2 and the 3, okay? So how's that different from what we did before? Before we were finding the product of just C. Now we're finding the product of 2 times 3, or A times C. Okay, see that difference? Okay, now we're going to use, the third step in this process is we use grouping to find the factors, all right? And then we've already learned how to do grouping. So we're going to write the product with the pattern that we know, right? So we have 2x squared plus 5x plus 3. And then, again, we're going to write it in this pattern where we have the mx plus px. So we'll take our two factors here, our two coefficients, and put them in here for the 2x plus the 3x, right? And so we've written it in that with those like that. Now we're going to group it. So you can see we've gone 2x squared. Oops, sorry about that, guys. So we'll group it 2x squared plus 2x and 3x plus 3. And let's see if we can't factor that. Well, look at here. Yes, we can. We can pull out a 2x out of the first group, and we can pull a 3 out of the second grouping. And we end up with 2x plus 3 times the quantity x plus 1. All right? Therefore, 2x squared plus 5x plus 3 is equal to 2x plus 3 times the quantity x plus 1. All right, we're going to do a few more of these, so don't worry. In fact, right now, our next slide, we're going to look at the concept in concept form, in the way we're used to looking at this in a general form. So here's your factoring of ax squared plus bx plus c. If you have trinomials, you're going to find, and we have ax squared plus bx plus c, you're going to find two integers, m and p, with a sum of b, right? And a product of AC. Okay? And then then this next step is you'll write it out like that. You'll write this as ax squared plus mx plus px plus c. And then you'll factor it by grouping. So there are 3 steps, right? There are 3 steps. First step is you find integers that have a sum of AC, a sum of B, and the product of AC. Sum of B, product of AC. All right. Then the second step is you write it as ax squared plus mx plus px plus c. And then the third step, you factor by grouping. All right? All right, see if this doesn't get you to be able to do these. Okay. All right, here we have one. 7x squared plus 29x plus 4. 7x squared plus 29x plus 4. Okay, so A is 7, right? B is 29, and C is 4, isn't it? So we need to find 2 numbers with a sum of 29 and a product of 7 times 4, or 28. Okay? So because, where's my little highlighter? Of 7 times 4, right? That's A times C. Maybe I should have written that up above. This is A times C, and this is the sum of B, right? Okay, so let's see what we can think of. What could we use here? Well, pretty quickly coming to mind is 1 and 28, don't you think? Right? 1 times 28 is 28, and 1 plus 28 is, of course, 29. So that works. So let me just check on what's our next. Okay, no, there's nothing there. Okay, so let's extend our page. I'm going to erase a little bit. We don't need all of that. Thank you. And now we're going to, so that's step 1. We found 1 and 28. Now we're going to rewrite it with as 7x squared plus mx plus px plus whatever we have, 4. Thanks. Okay. So we have 7x squared plus what is 1x, m is going to be 1, and plus 28 is going to be our px plus 4. Now we're going to, so step 3 then, we'll group. Is grouping. All right, now we're going to factor the grouping, right? And out of here we can take, what can we take out of our first one? We can take an x out, and that's going to leave us 7, right? 7x plus 1. And over here, what can we take out? We can take a 4 out, and that's going to leave us 7x plus 1. All right? Now we can factor it, and we can get x plus 4 times the quantity 7x plus 1. Okay, everybody good with that? Good. Let's try another one. Sorry, I have the sniffles a little bit, guys. 3x squared plus 15x plus 18. All right, well, the first thing I notice here is all of those have something in common to start with. And here's our study tip. It says, look for the greatest common factor of the terms of a polynomial before you factor. So I notice they all have a 3, don't they? And if I pull the 3 out, that leaves me x squared plus 5x plus 6. Okay? Then I'm going to keep that, I'm going to remember that 3 and I'm going to leave it. Now I'm going to try and factor the x squared plus 5x plus 6. But I will need that 3 again later. Okay? So keep it in the back of your mind. So let's factor this. And what do we get, when we factor this? Well, the product that is 6 and the sum that is 5. All right? So, of course, 3 and 2 comes to mind, right? So this will factor to x plus 3 and x plus 2. Oh, but let's remember our 3. It comes down. So that would be the solution. The factors of this product right here. That's saying that 3 times this will give us our original trinomial. All right, let's try something else here. This is not a very long lesson. We're halfway through already, guys. There's your guided practice. Try those two. We'll have, who should we have put them up on the board tomorrow? Well, we'll find somebody. I won't put you on the spot right now. But it could be Andy. I'm trying to think who I haven't had up at the board lately. Maybe Andy and Rena in one class, and maybe who haven't I seen at the board lately at the other class? Kyle and Isabel. All right. Good luck. Okay, sometimes the coefficient of the x term is negative. Here we have ax squared minus bx plus c, okay? Basically, it's the same things are going to happen. In this trinomial, right, you'll notice that a equals 3, b equals negative 17, and c equals 20. So since b is negative, m plus p is going to have to be a negative answer, right? And c, since c is positive, m times p will have to be positive. So we know how to figure that. So let's look and see what we can do here. So the product of a and c, right? So 3 times 20 is 60. And the sum has to be negative 17. Okay? So let's see what we can come up with. And we start thinking, and we get negative 2. Right away I think of negative 2 and 30. That's easy. But, those two added together. Oh, excuse me, we're going to have a positive 60. So both numbers are going to have to be negative. So negative 2 and negative 30 isn't going to work because that makes negative 60. Negative 3 and 20, negative 20 isn't going to work for the same reason. That's also, that's not negative 60, I beg your pardon. It multiplies to negative 60, but it's a negative 32. And negative 3 and negative 20 is a negative 23. And 4 times 5 is 6, or excuse me, 4 times 15 is 60. And I make those both negative. That leaves me with a negative 19. That doesn't work. How about 5 and 12? 5 and 12 both negative. Negative 5 plus negative 12 is negative 17. So that's us. There's our money. Okay, so now we rewrite. I'm going to extend our page, guys. We're going to rewrite using these two factors, right? 3x squared minus 5x minus 12x plus 20. Okay? And then we're going to group. We'll group here, and we'll group here. So we have 3x squared. So what can we pull out of 3x squared? And what I'm actually going to do right away is I'm going to change this to plus negative 12x minus 20. Okay? Everybody see why I'm doing that? Okay, good. What can we pull out of, you know what? I'm going to group them differently. I'll tell you why I'm going to do that. You'll see. If I do 3x minus 12x, I have a 3 in common here, right? I didn't have anything with the 3 and the 5. That's why I switched it. And so then that leaves me with minus, 5x plus 20. And that also gives me factors that have something in common that I can work with. Do you see that? The 5 and the 20. Okay, but let's go ahead and change our signs. Plus negative 5x minus 20. All right, now we can pull our 3 out, and actually we can pull out a 3x, can't we? We'll pull out our 3x, and that leaves us x minus 4. Plus, what can we pull out here? We can pull out a negative 5, and that leaves us x minus 4. Okay, so this can change to just a minus now, right, guys? So we'll get 3x minus 5 times x minus 4. Everybody good with that? Good, because here are a couple for, that was that problem. If you want to look at it again in nice, neat handwriting, there it is for yourselves. But we've just already did that entire thing, so either way. All right, here are your practice problems. Go for them. And we'll put these on the board too, of course. And please, don't worry if you don't get it right. Try it. We'll figure it out. It's a group project. Okay, prime polynomial. Here's our definition for the day. A prime polynomial is a polynomial that cannot be written as a product of two polynomials. It's called prime. So how do we figure that out? We have to determine whether it's a polynomial or not. And the way we do that is we take our 4x squared minus 3x plus 5, all right? If the polynomial cannot be factored using integers, then we're going to think that it's prime. So what we'll have to do is we know a equals 4, right? I think this laundry list is a good idea just to keep everything straight. B is negative 3 and C is 5. So we need factors of 4 times 5 or 20, and we need a sum of the factors that equal B, which is sorry, they're making noise outside, so I got distracted. Which is negative 3. Thank you. Thanks, guys. All right, so we start looking, and you look at negative 20 and negative 1, you know that's not going to work. You look at 4 and 5. Are 4 and 5 going to work? Negative 4, negative 5. Well, that certainly equals 20, but it doesn't equal negative 3, right? It equals negative 9. And we have to find something that will work for both. We try negative 2 and negative 10. That doesn't work either. So nothing works. So therefore, there are no factors. So therefore, it's prime. Okay? All right. Here are a couple practice problems for you guys. And that is it. That is our last slide. Nice short recording for you for the weekend. You all have a nice weekend now, okay, guys?